The integral from 0 to pi over 2 of x sine of 2x dx can be worked using integration by parts. We have an algebraic and a trigonometric term. Let u be the algebraic term, dv be the trigonometric term. The derivative of x is 1 dx. The antiderivative of sine 2x is a negative 1/2 cosine 2x. If you were to take the derivative of this term, you would get negative sine 2x times 2. In order to cancel out the negative and the 2, you have to rebalance with a negative half. Our expansion, we start with u times v, negative 1/2 x cosine 2x. We're going to evaluate that at our upper and lower values of the integral. Minus v du. Minus a negative is going to be a plus 1/2 cosine 2x dx. In this first half, we have negative 1/2, and then we substitute pi over 2. Pi over 2 times cosine of 2 times pi over 2. Your 2's cancel. Cosine of pi is negative 1, so that gives us negative pi over 2. 0 times cosine of this is going to be 0, just simply by multiplying by 0. So we have negative 1/2 times negative pi over 2 for positive pi over 4 out front. Now the integral in the back that is double underlined, that's positive half, and I just recopied it here so we didn't lose it. All of this is the first half of the expansion evaluated at the pi over 2 and 0. Now we can work on the integral in the back half, 1/2 times the integral from 0 to pi over 2 of cosine 2x dx. That's going to be 1/2. The antiderivative of cosine 2x is 1/2 sine 2x. Evaluated at our upper and lower values, that's going to be 1/4 sine of 2 times pi over 2 minus sine of 2 times 0. Sine of 0 is 0. Sine of pi, after you cancel these 2's, sine of pi is also 0. So this entire back half goes to 0. Our exact value is pi over 4. Our approximate value is 0.785. In the next example, we have the integral from 0 to 1 of x times sine inverse of x squared dx. Inverse trig ranks higher than algebra, so u is sine inverse of x squared. Remember our gnarly formula from class? We have 1 over square root of 1 minus our u value, which is x squared, quantity squared. That derivative is 2x. So by chain rule, we have 2x over square root of 1 minus x squared squared dx. The antiderivative of x dx is 1/2 x squared. Going back to the original problem, uv, that's 1/2 x squared sine inverse of x squared, evaluated at our upper and lower limit values, minus the integral of v du, which is really nasty. That blue 2 and this black 2 will cancel. I went ahead and wrote it all in here, but here in red, I canceled those two. And that gives us x cubed over radical 1 minus x to the 4th. Starting at the first half, we have 1/2, and then we can substitute in the 1 and the 0, so that's going to be 1 squared times sine inverse of 1 squared minus 0 squared times sine inverse of 0 squared. Well, all that goes to 0. 1 squared is 1. Sine inverse of 1 is pi over 2. So this first half becomes 1/2 times pi over 2, which is pi over 4. That's all in the first half. The latter half, or back half, we have a minus. In this green bracket, I cleaned up this fraction after the cancellation of the half and the 2. So we have x cubed over radical 1 minus x to the 4th dx. Nothing was done except clean up here. If we select 1 minus x4 as our u value, its derivative is 4x cubed. We have the x cubed, but we don't have the 4. So be very careful here. If we introduce a 4, we have to rebalance with a 1/4. This becomes 1 over square root of u du. 1 over square root of u is 1 over u to the half. Bringing that to the numerator is u to the negative half. Don't forget out front we have a 1/4. Now I didn't write it. We went over it in class, and this is just to keep the clutter down. But u to the negative 1/2. When you take the antiderivative, you have negative 1/2 plus 1, which is positive half, and that's still a radical. Dividing by a half is the same as multiplying by 2, so this 1/4 that I haven't written out front times 2 is where this 1/2 comes from. And so the antiderivative of what's in the green bracket is 1/2 times the square root of 1 minus x to the 4th, and we're going to evaluate that antiderivative at 1 and 0. And let's do that. So this is the same half. Substitute in a 1, substitute in a 0. This goes to 0. 1 minus 1 to the 4th is 0. Square root still 0. Back here we have a minus square root of 1. 1/2 times negative 1 is negative half. So overall, our final value is pi over 4 minus 1/2. If I were to sketch in that derivative, we have a 4 here. We would rebalance with a 1/4 out front. This would become, now I'm not going to lose the negative, but I'm not going to write it in here. Let's see, let me erase that. When we convert that to notation, that's going to be u to the negative half du. This is what I was talking about earlier when I was saying if you take the antiderivative, you add 1 to get u to the positive half, and that's why this radical is up in the numerator now. Dividing by a half is the same as multiplying by 2. 2 times the 4th is 1/2. The integral from 0 to 3 of e to the x sine x, this is an example of one that puts you in an infinite loop. When you have exponential and trig, specifically sine and cosine, a lot of times you'll get stuck in an infinite loop, pretty much every time. Trig ranks higher than exponential, so u is equal to sine x, its derivative is cosine x dx. Exponential e to the x dx, its antiderivative is e to the x. uv minus the integral of v du. I'm going to leave e to the x sine x just as it is. This integral is also exponential times trig. Let u be cosine of x. dv is e to the x dx. The derivative of cosine x is negative sine x dx. The antiderivative of e to the x dx is still e to the x. Underlined in pink, we have uv minus the integral of v du. These two negatives will make a positive. So what we've done is once I make that a positive, we have run, actually I'm not going to make it a positive because we have a third negative. But we have recreated the original problem. So the integral from 0 to 3 of ex sine x dx is equal to e to the x sine x minus e to the x cosine x minus, it's 3 negatives, so minus the integral of ex sine x dx. Now because our original problem and this last integral are identical, if I add this integral to the left side, it creates 2 of my original problems, and that is going to be equal to ex times sine x minus cosine x. Divide both sides by 2, and that takes us back to our original problem. Dividing by 2, I'm going to write it as 1/2, is 1/2 e to the x times sine x minus cosine x. Evaluate at 3 and 0. I haven't brought those up yet because I haven't wanted to put the numbers in. Once I figured out what my integral is, now when we evaluate at 3, we have 1/2 e cubed sine of 3 minus cosine 3 minus, and then we put that lower value in, e to the 0 times sine 0 minus cosine 0. E to the 0 is 1, sine 0 is 0, cosine of 0 is 1. So we have 1/2 times e cubed times sine 3 minus cosine 3. All this back here is negative 1 times negative 1, which is positive 1. And that's the exact value of that integral. And then finally, we have an integration by parts where I just want to show you a tabular value or tabular method. If you have to do repeated integration by parts, you can set up a table and make it go a little bit more efficiently. Now, what you'll want to do is create a table starting with positive, negative, positive, negative. I recommend at least 4 rows. Sometimes you have to go longer depending on how large this exponent is in your problem. We have algebraic times a trig. Algebra ranks higher, so u is going to be that algebraic term, x plus 3 quantity squared. Trig ranks lower, that's our dv, sine x dx. In the middle column, you continuously take derivatives until you reach 0. In the dv column, you continuously take antiderivatives until you get to the same row where your 0 is located. And this one, it happens to be row 4. Then, to write out your antiderivative for the original problem, you start with your sign. So you have positive u. Now, on the dv column, you have to slant downward a row. So it's positive x plus 3 quantity squared times negative cosine x. I'm going to go ahead and float that negative out front, but basically it's negative x plus 3 quantity squared cosine x. Then you go to the second row, minus 2 times x plus 3 slant downward times negative sine. Well, these two negatives make a positive 2x plus 3 sine x. Third row, we go back to positive 2 slant downward cosine x. And then we finally don't have to go to row 4 because where we've created the 0, there's no use going through it. Don't forget your constant of integration plus c.